left hand and a right hand way. And then finally, I think we took a brief look at domains.
Very nice, Tyson. Appreciate. Very nice. Okay, let me share the screen now. So that's what we covered yesterday. And today, now we are going to start. Can you see my screen?
Yes, sir.
Okay, so today we are going to start with this one. I told you this is the example number 3 from your practice test. And it says that y equal to 1 over x square plus c. That is the general solution of the differential equation y square plus 2xy square equal to 0. Again, how to solve the equation that I will let you know in chapter 2. And y at 2 equal to 1 by 3. This is the initial condition. Value of the y at x equal to 2 is 1 by 3. So whenever differential equation with some initial condition, that is called the initial value problem. Differential equation with some boundary condition, that is called boundary problem. We are not going to do much about the boundary value problem in this course because of the limitation of time, but we will be doing lots of things with the initial value problems. So initial condition is fixed, that is called the initial value problem. If this condition, here it is y2 equal to 1 by 3 and y4 equal to 5, something like that. That means it is called boundary condition. But y2 equal to 1 by 3 and suppose y dash of 2 equal to 5, something like that. In that case, because this 2 is fixed, that is called the initial value problem. So please keep this thing in mind. Okay, the question is, so yx equal to 1 over x square plus c, and we want to find the domain. First of all, what is the value of c using this initial condition? Yesterday, I told you that initial condition that is always useful to get the value of your constant c. Initial condition is always, initial condition provides, or that is the usefulness of the initial condition to get the value of the constant. So that's what we are going to do over here. First of all, y of 2 equal to 3. So just let me plug this value in the solution. Let me plug this value in the solution. This is my solution of the differential equation. How to get this solution? That is pending work we are going to see in the next chapter. But right now, let me accept this one. And y at 2 means if I replace x by 2, here also, I'm going to get y at 2 equal to 1 by 3. So y at 2, this yx equal to 1 by 3. This yx is replaced by 1 by 3 equal to 1 over x is replaced by 1 by 3. So x is replaced by 2. 2 square is 4 plus c, so 4 plus c. If you take this one in the numerator, you're going to get 3 equal to 4 plus c. So c equal to -1. Just go back and plug this value of c over here. That means I'm getting y at x equal to 1 over x square minus 1. 1 over x square minus 1. Now I want to fix the domain of this solution function. Domain of this solution. Solution operator, you can say. Y at x equal to 1 over x square minus c. Now 1 over x square minus c, yesterday I told you that whenever you want to fix the domain, at that time you have to be very careful. You have to think about the points for which your function is not defined. So here I'm going to get y equal to, or y of x equal to 1 over x square minus 1. 1 over x square minus 1. For which point this function is not defined? I'm talking about this one, 1 over x square minus 1. For which point this function is not defined? If I take x is equal to 1, then 1 over 1 minus 1, that is 1 over 0. 1 over 0 is infinity, not defined. Agree?
Yes, sir.
Agree?
Yes, sir.
Yes, sir.
Okay. So if I take x equal to -1, then -1 square is again 1. 1 minus 1 is 0. 1 over 0 is infinity. So function is not defined for x is equal to plus or minus 1. That means I have to exclude these 2 points from the domain. So my domain for this solution operator is this one. Look at here. That is equal to r minus bracket plus minus 1. So from the whole real line, -1 and 1, these 2 points are excluded. And rest of the points, they are the domain of this solution function. Rest of the points are the domain. Rest of the functions are included in the domain. Rest of the points are included in the domain for this solution function. Are you getting me?
Yes, sir.
Are you getting me?
Yes, sir.
Yes, sir.
Good. Yes, Alex?
Yes, sir.
Good. So that is the solution function, right? Solution function. Now, what is the graph of 1 over x square minus 1? Graph of 1 over x square minus 1 will be something like this. you know how to plot the graph, right? Again, your Calc 1 course, you went through application of derivative, you went through derivatives, then increasing and decreasing function as a first application. Then after you went to the concavity, concave up, concave down, you found the domain, you found x-intercept, you found y-intercept, you found the domain in which your function is increasing or decreasing, you found the domain in which your function is concave up and concave down, second derivative test. And after all these things, you found the maxima and minima. And after all this, after taking the summary of all these applications, finally, you would be able to plot the graph of the function. So if you apply the same technique over here, you are going to get the graph of the function something like this. At 1 and -1, function is not defined. 1 and -1 function is not defined. Actually, 1 and -1 will give you an asymptote where your graph of the function will not touch. That is called the asymptote. And graph of the function will look something like this. Graph of function will look something like this. All of you can see my picture?
Yes.
Yes, sir.
All of you?
Yes, sir.
Mm-hmm. Right? So domain of my solution is r minus plus minus 1, r minus -1 and 1. So I would say like this, that -infinity to -1, open interval, -1 to 1, union, 1 to infinity. This is the domain of my y, domain of yx. Like this, domain of yx is given like this. Nina, are you getting me?
Yes, sir.
Margie,
Yeah, I'm getting it.
where are you? I don't see your picture. Please keep your camera on, please, guys. This is the domain of your solution operator. But that means solution exists. Look at here. Solution exists in this domain, here to here, here to here, and here to here. But you are given the initial condition like this: y at 2 equal to 1 by 3. Y at 2 equal to 1 by 3. That means when x is equal to 2, value of y is 1 by 3. X is equal to 2 lies over here. Look at here. Look at my finger. X equal to 2 lies over here. So here it is 1 and 2 somewhere over here. And this is your 2 and 1 by 3 point. 2 and 1 by 3. Can you see here? Yes or no?
Yes.
Yes, sir.
Right? Because my initial condition lies only in one part of the whole domain, this R, one part of the domain. That means this is the domain of this one, but domain of initial value problem that is equal to only 1 to infinity. Domain of initial value problem is just 1 to infinity, because my initial value lies only in that particular domain. So question number 3, I ask you to fix the domain of your solution operator as well as the domain of your initial values. Look at over here. So domain of y, that is this one. Domain of y is this one. So that's the reason. So I solved example number 3. Now let's go for example number 4. Example number 4, that is the second order differential equation, x double dash plus x equal to 0. I told you yesterday, order of the differential equation must be equal to number of initial conditions if it is an initial value problem. Because order 2, you have to have 2 conditions. But 2 conditions are not just related to your x. One relates with x, another relates with x dash. Please keep in mind this thing. Why it is called initial condition? Because this 0 and this 0 are same. If this one is 0 and this one is 1, it is called boundary. It is not the initial. So initial points are same. That's why it is called, initial point is same. It is called initial value problem. X double dash, first condition that relates with x, second condition relates with x dash. 2 conditions are there. If you solve this equation, we are going to see this thing in chapter 4 because this higher order differential equation phase 2, chapter 4. Right now, accept the solution. If I plug this, if I use this solution and plug the value, my first initial condition x at 0 equal to -1. X at 0 actually is a function of t, x at t equal to this one, like this. So x at 0 equal to, x at 0 equal to 1 or -1? Here it says -1, I took 1 over here. I think my bad, I'm sorry. Just take x at 0 equal to 1, that's fine. Don't take -1, it's just 1, okay? That's my bad, sorry. Anyway. No, let me remove this part, I don't want it. But it is +1. Okay, so it is 1. Cosine 0 is 1. Sine 0, 0. So C1 equal to 1. Once C1 equal to 1, go back and plug the values first. Go back and plug the value first. So xt equal to cosine t plus C2 sine t. Cosine t plus C2 sine t. Now my second condition relates with the derivative, velocity function. And that's why I want to take the derivative of my solution operator. So take the derivative, x dash t. Cosine t is negative sine t. Sine t is cosine t, C2 constant. My condition x dash 0 equal to 8 means when t equal to 0, x dash is velocity is 8. Let's put the value 0 here. So C2 equal to 8. Plug this value of C2 in my xt. Don't plug it in x dash. We are working with your solution. So cosine t plus 8 sine t. And that is the solution. So that is your example number 4. Order of the differential equation must be equal to number of arbitrary constants. Now, how many constants are there? Look at over here. I forgot to let you know this thing. Order of the differential equation, second order, 2 arbitrary constants, C1 and C2. We just figured it out. My C1 is 1, C2 is 8. That's a different thing. But order of the differential equation must be equal to number of arbitrary constants in the solution. So if your order is 2, you have to have 2 arbitrary constants in your solution. If your order is 3, you have to have 3 arbitrary constants in your solution. But don't think that order is 2 and you can work with just 1 or 1 arbitrary constant. No, it has to be same. Good. Now let's go for question number 2. I solved question 1 yesterday, question 3 and 4 right now, and now I just go back to question number 2b. Anyone from 2? I solved question 2a part also yesterday. That was the verification. Yeah, e to the power mx, always keep your practice test in front of you. It is there in my mind, so I can give you the complete thing. But for you guys, I think it is better if you keep a hard copy in front of you every time, every lecture, every moment. Because in just one lecture, I am going to use the formula, your practice test assignment more than 7 to 10 times. So keep your practice test in front of you before class starts. Every day, every day. If you want to, if you don't have the printout and if you want to take the printout right now, I can give you some time. You want it? I'm asking you guys. If you want to take the printout right now, if you have a printer at home, I can give you some time. You want some time?
I don't have access to a printer right now, so I'd probably just do that in class.
Yeah, I'm fine for right now. Because I have it pulled up on my computer.
Yeah, there's always just keep that one in front of you. Good. So y equal to e to the power mx, and that is the solution of this first order differential equation. Y dash plus 2y equal to 0. And we want to find m. What is the value of m? This is just kind of verification because it is y dash first derivative. So let me take the derivative of this solution. So m e to the power mx. Plug the value over here, this value and this one. So m e to the power mx and y equal to this one. So I'm getting this one. take e to the power mx common, m plus 2 equal to 0. But exponential function like this never be 0. It's an increasing function, never be 0. So if you use zero product rule over here, zero product rule, either e to the power mx equal to 0 or m plus 2 equal to 0. But e to the power mx never be 0 because it's an increasing function. So you have only one choice, that is m plus 2 equal to 0, m equal to negative 2. Just go back and plug this value over here. So y equal to e to the power negative 2x is the solution of this differential equation. Negative 2x is the solution of this differential equation. That is just part B. So we finished article 1.1. Yeah, it's a lengthy article. Now we are going to start the next article, that is article 1.2, initial value problem. Article 1.2, initial value problem. Look at over here, dy by dx means it's simply a velocity. X at y0 equal to y0. That's the initial condition. Means this is initial value problem. So this velocity function, solution of this one is a family of solution. I told you yesterday. Out of this all family of solutions, your point x0, y0 lies on just one of the families, one of the curves. Suppose that lies over here. That means solution of this initial value problem will not be the whole domain. This is just this domain, this one, only this one. That is the solution of the initial value problem. So keep in mind this thing, and that's what we figured it out in our example number 3, right? I told you that we have big domain as a solution, but initial condition lies just in one part. So it's always restricted. So solution of the initial value problem is always restricted. Second, this is called the geometrical interpretation of the first and second order initial value problems. Second order initial value problem, d square y over dx square equal to f x y and y dash, x y0 equal to y0 and y dash at x0 equal to y1, right? So y at x0, that lies over here, and y dash is a velocity, means if this is a slope, it's a slope. So slope passing through this point x0, y0, x0, y0. So slope passing through this point, right? So first condition is this one, that point lies over here on the solution. Initial condition lies over here, displaced on the solution. And the second one is the velocity function, slope passes through that point. So domain of this one, or solution of the initial value problem and solution of the second order initial value problem. This is the only solution of second order initial. These all are the solutions. All are the solutions of the second order initial value problem. That is the geometrical picture. So naturally, question arises, just I told you yesterday that what is the guarantee that we are always going to get the existence, or is it possible to get the uniqueness of the initial value problem? See, this is the solution. This is the solution. I agree. Is it possible that always we are going to get a unique solution, or in which condition we will be getting the unique solution of the initial value problem? So that is very important thing. Initial value problem, existence and uniqueness of the initial value problem. You are going to get one question based on this one in your internal and the final. So please be careful. Existence of the initial value problem. Existence of the initial value problem. All of you are present today. I just want to see you guys. Please say something.
I think everyone's
One by
present.
one. One by one, please. Give your name.
Alistair, I was here.
Second. Next.
I was here.
Next.
Light.
Next. Next, please go ahead.
Margie's here.
Elias is here.
Mm-hmm.
Nina is here.
Mm-hmm.
Will's here.
Next.
Quinn is here.
Okay.
Shmuel's here.
Quinn is here.
Gage is
Next.
here.
Okay. Next.
I think that was everyone, sir.
That's it. Okay. Okay, guys, please pay attention here. I'm going to use this theorem 3 times actually in this semester. I'm going to say in this course. And I'm not going to speak the whole theorem every time. I will just recall like this, theorem 1.2.1. 1.2.1, that's the number given to you in the book, Zill's book. So whenever I say theorem 1.2.1, it is to be understood that we are talking about the existence and uniqueness of the initial value problem. Okay? Existence and uniqueness of the initial value problem. Let be a rectangular region in XY plane. Look at here. This R is a rectangular region in XY plane defined by x equal to a is this line. Look at my cursor. X equal to a is this line. X equal to b is this line. Y equal to c is this line. Y equal to d is this line. So hold this region, that is my R. That is my R. So R be a rectangular region defined on XY plane by x equal to a is less than or equal to x is less than or equal to b because a is less than b. Look at here, x lies in between. C is less than b, y lies in between. Means that's the thing. That contains the point x0, y0. One point x0, y0. Don't look at this solution. Just one point x0, y0 lies in this rectangular region. Square region or rectangular region, or it may be. One point x0, y0 lies in this region. If f of xy means my function and its partial derivative, how many of you have already gone through Calc 3?
I have, sir. It was a long time ago, though.
Long time ago. Long time means what do you mean by 2 years?
I think I took it third class year.
Okay. What's your name? Who is there?
Hostetler. I'm the graduating first classman.
Okay, got it. No problem. I told you we are, yesterday I told you that we are using just 5% of Calc 3 in this course, but 80% of Calc 2 in this course. Am I right? And this 5% I will teach you. Don't worry. I will let you know. This del f by del y, that is called the partial derivative, not the full derivative, partial derivative of f with respect to y. First of all, what we mean by the partial derivative? Suppose I give you one function. Partial derivative. Suppose I give you one function. Partial derivative that is possible only for the function of 2 variables or higher variables, more variables. For function of one way, y equal to fx is just full derivative. But if it equal to z equal to f of xy, z equal to f of xy, we can go for the partial derivative. So partial derivative del f by del x. Suppose I have one function f of z equal to f of xy equal to x square plus y square plus 2xy square plus 2x square y, or 3xy square and 3x square y. Suppose I have this function. Okay. Now I want to find the partial derivative of f with respect to x. Now make sure whenever you write partial derivative means del f by del x. At the same time, how many variables are there? 2 variables. 2 variables means x and y, 2 independent variables. Z is a dependent variable, depends on x and y individually. Are you getting me?
Yep. Yes, sir.
Nina, Margie?
Yes, sir.
Okay. So del f by del x, that is equal to, whenever you are del f by del x, I usually write suffix y. Means y is constant. Y is constant means just consider that as some fixed number. Y is constant. So what is the derivative of x squared with respect to x?
2x.
Oh my God. Yes? 2x, right?
Yes, sir.
Good. What is derivative of y squared with respect to x? Y is constant, please.
If y is a constant, would it be 0?
0. Good. So I can write 2x plus 0 plus 3 constant. Derivative of 3xy squared with respect to x. Y is constant. Y is constant. 3 is constant. So let's y
So
squared
it'd be 3y
constant.
squared.
Constant, and derivative of x is simply 1. Agree?
Yes, sir.
Derivative of x with respect to x is simply 1. Am I right?
Yes, sir.
Yes, sir.
Okay. Last part. Margie. What is the derivative of the last part?
Sorry, can you repeat that? I'm having trouble hearing you.
I said, what is the derivative of last part? 3xy square? What? Yeah, 3x square y.
Okay, so the y 6x.
Just 6x.
6x.
Your y is constant.
So 6xy.
6xy, you got it. Right? So that is equal to, you can write like this. Y is constant, 3y is constant, derivative of x square is 2x. That's the best way of writing. Agree?
Okay, so you don't combine them.
No, you can, but just to learn the
Better.
things first time, it is better to write every step separately.
Okay.
Right? Good. That means you are getting 2x plus 3y square plus 6xy. That is my del f by del y. Agree, guys?
Yes, sir.
Now, my second part is del f by del y means x is constant. Del f by del y, x is constant. Nina, what is derivative of x square?
2x.
X square with respect to y.
Isn't it just 2xy? 2.
Wrong. You are taking partial derivative with respect to y. Your x is constant. So what is derivative of x square? X is constant.
2.
Elias
Is it just 0?
is 0. X is constant, so the derivative is 0, right? So 0. Derivative of y square with respect to 2y. With respect to y.
Just 2y.
2y. Good. Derivative of 3xy square with respect to y means 3x, x is constant. So 3x is constant. Derivative of y square, Lx.
3x 2y.
3x to y. And 3x square y. X, 3x square is constant. What is derivative of y with respect to y? Derivative of y with respect to y.
Oh, it'd just be 3x.
Derivative of y with respect to y is simply 1, right? So that
Yeah.
is 6xy, 2y plus 6xy plus 3x square. 2y plus 6xy plus 3x squared. That is the answer. Agree?
Oh, it was squared at the end. I didn't see that.
Yeah, it is square. 3x.
Okay. Yeah, I missed that.
Right? So that's what we mean by the partial derivative. Simple.
I have a question. For the first one, why didn't it just stay as x squared? If it's with respect to y, wouldn't you just leave the x alone?
No. X is a variable, but it is constant. Derivative of constant. Oh, sorry. Where I was. X square. Yeah, derivative of function with respect to y. X is treated as constant. Agree?
Oh, so if it's an x, you just treat it like a 1 or something, right?
No, x is treated as constant. Suppose x is equal to 1. So derivative of 1 constant with respect to y is 0. Agree?
Yeah, for the other one, when it was respect to y, you still took the derivative of x. Or no, you just left it as it was.
Oh my gosh, Gargi. What is this? I got your question. Okay. Guys, did you get her question? She says that here I wrote it down, derivative of x with respect to y is 0. Then why I took this 3x this
Oh,
side
multiply.
and 2y. That's the question. Good question. Who wants to take this one? Why I can't see your picture, Margie?
You not?
No.
I'm
Oh,
not.
the reason you don't make it 0 is because it has a y next to it, so it's or with it in the same function, right? Or the same.
All.
Yeah, it's
Solomon.
one of the
Yep.
constants multiplied by a variable, and you
Yeah.
take the derivative of it. You multiply the constant by the exponent, and then drop the
That's what Alex said, right? Actually, it's a product rule, guys. See, consider like this. Where is it? My function was like this, 3xy square. And for derivative of this function with respect to y. So with respect to y means, first of all, 3 outside, x as it is, and derivative with respect to y, del by del y of y square, plus y square as it is, and del by del y of x. Can you see here, Margie? This one?
Yeah.
Right?
Yeah.
It's a product rule.
That
I just
makes
took 3x square y, 3 outside, and I took the product of x and y. So derivative of x with respect to y, and then y square constant and vice versa. Now what will happen? That is equal to 3. X as it is. Derivative of y square with respect to y. Derivative of y square with respect to y is 2y. Agree?
Yeah.
So it is 2y. 2y. Plus y square. Plus y square. X is constant. Derivative of x with respect to y is 0. Agree? Margie, I'm asking you.
Yeah, I agree.
So that is 0. So that is equal to 3x and 2y. Because other part is 0. Agree?
Yeah.
So what is left out? So that is equal to 6x and y. Agree? That's why I wrote it down here, 6xy. Look at here. Make sense?
Yeah, that makes sense. Thank you.
Okay. So that's what we mean by the partial derivative. Now let me continue. That's what we mean by the partial derivative. It says that, oh, let me just do this one. Okay. It says R be a rectangular region in xy plane defined by x equal to a, x equal to b, y equal to c, y equal to d contains the point x0, y0 inside the domain. My function and its first partial derivative is continuous in R. That means in this region, my function and its first partial derivative with respect to y only, that is continuous. Then, if these conditions are satisfied, that f and f, del f by del y, both the functions are continuous over here in the region, this condition is satisfied, then this is the symbol of there exists, please. There exists some interval I0. Some interval I0, that is x0 minus h to x0 plus h. x0 is this point. x0 is this point. y0 is this point. x0 is this one. So x0 minus h is this one, y0 minus. That means your domain is slightly restricted by this interval x0 minus h to x0 plus h, where h is positive. So x0, suppose x0 is here, x0 minus h is 2. So x0 minus 2 is here, x0 plus 2 is over here. Both sides, so it's the interval. So there exists some interval like this in the interval a to b, contained in interval a to b, and a unique function yx defined by y0, that is the solution. Unique function yx defined on I0, this is the interval I0, this interval I0, defined on I0 is the I0, that is the solution of the initial value problem. So this is a theorem. I know you are not getting the full things over here. I will solve the example and you will have a complete idea. Okay, good. Just open your practice test, backside, question number 5. Practice test, backside, question number 5. This is the example of another partial derivative, another example, 2x squared y. And anyway, did you open that practice test? Question 5.
Yeah, the determine whether
Yes, sir.
that one.
Yes,
Yes.
sir.
Yes, Gargi, read the example.
Oh, you want me to read it?
Mhm.
Determine whether the differential equation y1 equals the square root of y squared minus 9 possesses a unique solution through the given point, and then there's 4 points.
Right? Don't say y1, say y dash.
Okay.
Determine whether we are getting a unique solution of this differential equation dy by dx, y dash equal to y square minus 9 square, y square minus 9, right? In the given domain or not. So first of all, dy by dx equal to y square minus 9. What is the domain of this function? Any one of you? What is the domain of the function y square minus 9? My gosh, we discussed
Plus
yesterday.
or minus 3, right?
Plus or minus 3? Minus 3 will give you 0.
Isn't it everything? Wait, hold on 1 second.
Suppose I take, let me give you the hint. Suppose I take 2, then what will happen? Y equal to 2. Then
And that would be negative. So it's everything above 3.
above 3.
Yeah, okay.
What's about negative 4?
Everything in between
Okay.
except 3, positive 3, negative 3, correct?
Correct. Paul, you are right. You got it.
Okay.
Yeah, so everything
Of
except
course.
the interval negative 3 and 3, because negative 3 and 3 will give you the value less than 9. Between the value, any point between negative 3 and 3 will give you y square minus 9 less than 0. Am I right?
Yep.
That means
Yes.
y has to be greater than 3 and less than negative 3. Greater than 3 and less than negative 3. So I have to exclude this domain from the real number to fix the domain of this function. So domain is y square minus 9. This inside must be greater than or equal to 0. Y minus 3, y plus 3 is greater than or equal to 0. So y is greater than or equal to 3 and y is less than or equal to 3. This is the domain. This is the domain. Now y is greater than or equal to 3 and less than or equal to 3. That means what happened? Oops. That means, just look at over here. Let me draw the picture. This is my line y equal to 3 and this is my line y equal to negative 3. This is my x-axis and this one is my y-axis. Just look at here. Oop. Y equal to negative 3, positive 3, x-axis and y-axis. Y is greater than or equal to 3 means this is the domain. Greater than or equal to, equality is there. Means my domain includes this line. Am I right?
Yes.
All of you?
Yes, sir.
Yes,
Yes, sir.
Good. So I just fix a domain for my given function. And this domain is my R. If you compare this one with your theorem 1.2.1, this is my R. Now, my function is continuous. My function is continuous over here in this domain, right? Because this is the domain in which function is well defined. So my function is continuous everywhere over here and everywhere over here too. Now I would like to go for the partial derivative because my I have to check just two conditions. One is my function must be continuous in the domain. My partial derivative with respect to y must be continuous in the same domain. So partial derivative. This function, whatever is on the screen, fxy equal to y square minus 9, there is no x over here. So this is called the autonomous function, right? Just one variable, autonomous function. Why there is no x here? Okay. Okay. So my y is equal to actually my y dash is my f of xy. Just keep in mind this thing. Y dash equal to f of xy in my theory. So what my function is whatever dy by dx. Look at the cursor on the screen. Dy by dx is given to you. Dy by dx equal to y square minus 9. This dy by dx is equal to f of xy equal to y square minus 9 square root. So that is equal to square root of y square minus 9. And this function is well defined in this domain, continuous in this domain. This domain, I would say that is my R right now. Look at here, that is my R. Let me now take the partial derivative of my function f. My function f is this one. I just defined this one. My function f is this one. Y dash function. I'm taking the partial derivative of this f, means partial derivative of y dash. What is the partial derivative? Del f by del y. Square root y square minus 9. What is the partial derivative? Yes. Who wants to take this one? Partial derivative of this one, please, guys. Partial derivative of square root of y square minus 9. This one, this function. What is the partial derivative? Will Hostetler?
Yes, sir. I'm working on it right now.
Yes. Anybody else?
Sir, is it with respect to y or respect to x that we're
With
solving
respect
it?
to y, theory says with respect to y. Solomon, Paul, Nathan Light.
If it's in respect to y, wouldn't it be 0 since there's no y
Nope.
within the...
No, partial derivative with respect to y, and y is there. Square root of y square minus 9. Do you get there?
Oh, square root of y squared. I thought you
Y
said...
square minus 9.
My bad.
Yes. Is
2y.
take this one? Is Gag Levin? Gag or Gage? How you?
I don't know.
You
Wouldn't
don't know
it
your
be
name?
one? Wait, so it's...
Gag or, no, I'm asking. Levin, I'm asking your first name. Gag or Gage?
Gage, sir.
Say again. Gage?
Yes, sir.
Gage. Okay, Gage. Sorry, got it. Yes, Gage, you want to take this one?
No, thank you.
Is
So wouldn't it be 1?
just take the partial derivative of this one, y square minus 9.
Oh.
Or should it be 2y over radical y squared minus 9?
2y, then
2y over square root of y squared minus 9.
2y? No, you are slightly wrong. You are almost right, but that's not perfectly right.
Wouldn't it just be 1?
Queen Heart, I think he can help me. Queen Heart.
Is it?
Yes.
Is it 1/2 then y squared minus 9 to the power negative 1/2 2y?
1/2 y square minus 9 to the power negative 1/2, then
Times 2y.
correct. You got it. It's chain rule.
That's it.
Right? It's chain rule. See here, y square minus 9. Root x derivative is 1 over 2 root x. Right? So y square minus 9 root, that is equal to 1 over 2 square root of y square minus 9, and derivative of y square minus 9 inside, that is 2y. So you are going to get like this. You are going to get like this.
Sir, we can't see it.
Yeah, I can't see it.
You can't see, just wait.
You got to move it to the left.
Wait. Can you see now?
A little more.
Yeah, yes, sir.
A little more. Okay, there you go.
All right.
Okay, so 2 and 2 will get cancelled out. I'm going to get y divided by square root of y square minus 9. So what is the domain of this function now? Find the domain of this function. Who wants to take this one now? Y over square root of y square minus 9. Who wants to take this one? What's the domain?
Would it be the
Yes.
same but inverse?
Same, no. Same but inverse.
Wouldn't it be y has to be greater than 3?
What is that,
But-
Nina? Y is
Yes.
greater than, yes, you are right. Go ahead. Y is greater than 3. Why? Y is greater than 3.
And then y
Mm-hmm.
less than -3?
Correct. Why? You are right. Please explain. She said,
because you'll get-
1 minute. She said that domain is y is greater than 3 and y is less than -3. This is the domain. That's what she said. She did not say equality. She said greater than, strictly greater than, and strictly less than. Nina, explain why.
If you put 3 in the denominator, you'll get the square root of 0. So
And 1 over denominator, if you take 3 in the denominator, you are going to get 0 in the denominator. Means it is infinity, not defined.
yes, sir.
Right? And that's why you have to exclude those two numbers. That means my common region is this region. See this curly lines don't touch my y equal to 3 and y equal to -3. So this is my region, that is my interval I0. And in this region, my function as well as my partial derivative both are continuous. Agree? Both are continuous. Good. Now, I think you are given some points in the example. Just look at the practice test and give me the first point.
The first point is 1, 4.
1, 4. Where is 1, 4 lies? 1 is x-axis, 4 is y-axis. So 1 and 4 is 3. So 1 and 4 somewhere over here. Look at my finger, please. Can you see this point?
Mhm.
Yep.
What? 1 is here, 4 is here, so 1, 4 is over here. Agree? 1, 4 means when x is equal to 1, value of y is 4. Means y at 1 equal to 4. That is the meaning. Initial condition. 1, 4 is not just the point, it's the initial condition. So differential equation, see, look at the screen. Differential equation is this one. And the initial condition is y at 1 equal to 4. 1, 4 means y at 1 equal to 4. Y at 1 equal to 4. And that's why this point lies inside your domain, inside the common domain of the continuous function f and del f by del y. Agree?
Yes.
Are you okay? Nathan Light. Are you okay?
Yes, I'm okay.
Good.
Sir, I have a question.
Wait. Let me first finish this one. All of you agree with me?
Yes, sir.
Yeah.
That means my claim should be like this: y dash equal to square root of y square minus 9 with 1, 4 means y at 1 equal to 4. For this initial value problem, solution exists and it is unique. Solution exists and it is unique. So that should be my claim. My claim should be like this: y dash equal to square root of y square minus with y at 1 equal to 4. This is my initial value problem. Look at this elliptical figure. Look at this one. For this one, solution exists and it is unique. Solution exists and it is unique. Paul.
On the interval, why is greater than or equal to 3?
Here.
Well, like, I remember you saying that it can't equal to 3.
I said in the partial derivative, del f by del y, it could not be equal to 3. Here, your square root sign is in the numerator. Whenever your square root sign is in the denominator, that won't work. Look at here. Look at here. Del f by del y equal to this partial derivative, y over square root of y square minus 9. Here, if you write, so domain of this one is, if you write 3 over here, 9 minus 9 is 0. Anything divided by, or 3 divided by 0 is infinity. It's not defined. So because of this denominator square root in the denominator, you have to exclude that point. For numerator, you are going to get 0. 0 is a real number, but infinity is not a real number.
I understand that, but like right above it, where you wrote y is greater than equal to 3.
I'm not getting you. Slow down. I'm not getting you. Paul, I'm not getting you. Slow down. Go ahead.
I said right above that, y is greater than or equal to 3, and y is less than or equal to 3. How come you had the greater than equal to sign, and then below it, you don't have it?
Oh my gosh, I told you the same thing. I answered this question. You want me to repeat the same question, same answer? Okay.
No, I'm just wondering why you wrote the notation as greater than above it, when it was never equal to 3 or negative 3.
Who wants to take this one? Anybody else? Do you understood the question, guys? You understood the question or not? Guys, I'm asking you.
I think I get it.
Please
Well,
go
it's
ahead.
because up top where y is greater than or equal to 3, it's because it's in the numerator, and that's why it can be equal to. But when it's in the denominator, because when we saw through or like did the partial derivative, we found the domain of that is in the denominator, and we can't have it equal to. Is that correct?
It is correct, but I don't think that he understood this thing.
No, I understood that. I thought you would talk. I think I was a little confused. I'm sorry.
Let me explain to you last time. Here it is my.
I understand, sir.
You sure?
Yes, sir.
Okay. Any other question, guys? Are you okay?
All good.
Good. Good. Whenever you have, see, just think like this. For this function, y square minus 9, my domain is this. You don't have any problem over here, right? Paul?
No, sir.
Good. So just think like this, that this is my negative 3 and this is positive 3. Paul, look at here.
I see that.
If I take any number in between, I'm going to get my function y dash equal to y square minus 9 or f of xy, let me write. See, this function is not defined for any of the points in between negative 3 and 3. Agree? Because suppose you are taking 0, you are getting negative number inside this square root sign. Means it is complex, and that is not allowed because we are working with just real numbers. Are you getting me?
Yes, sir.
Okay. If you take 3, so here because 2.9 will give you negative. Negative 2.9 will give you negative. But if you take 3, 3 square is 9 minus 9 is 0. And 0 in numerator. See, fxy equal to 0. 0 is a real number. So it is defined. Agree? That means my domain will be this one, including negative 3 and positive 3. Am I right?
Yes, sir.
Good. Now I go for the partial derivative. So del f by del y, and that is equal to 1 over 2 square root of y square minus 9 and 2y. So 2 will get cancelled out, y over square root of y square minus 9. I want to fix the domain of this second function, del f by del y. This function. What will happen? Y is there in numerator. That y will work for any real number. But here, denominator, denominator, again square root of y square minus 9 function is there. Right? So, y square minus 9 must be greater than 0. Strictly greater than 0. Because if this y square minus 9, if this y square minus 9, suppose that is 0, then what will happen? Square root of 0 means 0. So y divided by 0, that is infinity, not defined. So because this function lies in the denominator, that makes this is 0, but this is denominator will make this one infinity. Are you getting me? And infinity is not defined.
Yes, sir. I was just a little confused that it was not in the denominator.
Right? So now for this part, my domain will be -3 and 3, but I have to exclude my 3 and -3, and everything will remain the same. So that will be the domain for my del f by del y. Does it make sense?
Yes, sir.
What is a common domain now? This one is a common domain because here -3 and 3 was included. Here we exclude. This is the common domain. And that's what we drew over here on the picture. I can't do anything more than this. Okay? Okay, guys. So now, what was the second point, Nina? 1
5.
was 1, 4. Second point was?
5, 3.
5, 3. Okay. If you use the same number, same figure, 5, 3 is over here. Look at here. Oops. 5, 3 is over here. 1, 2, 3, 4, 5. And 3 is over here. So 3. Is it a part of the domain? My cursor, my point? Is it the part of the domain? Oh my gosh.
Yes.
I feel like
Yes.
it's part of the domain.
Yes?
Yes, it is.
Are you sure?
But when you, it's not part of the
This is-
partial derivative.
Is 3 is not included in your final domain, in the common domain. See, look at here.
Oh, yeah.
Look at these lines. These lines these lines don't touch your 3. This cross line don't touch your 3. So this is not a common domain. So 5, 3 is not the part of the common domain. That means y at 5 equal to 3, this initial value problem will not be giving you the unique solution. Getting me or not? Gargi? No, sorry,
Yeah,
Margi,
if
I'm
you
sorry.
didn't-
I'm sorry.
If you didn't have a graph though, would you just plug the 5 in for y squared?
Say again, please.
So if you didn't have the graph and you just took the derivative of the given differential equation, would you just plug in 5 and see if the output is 3?
What do you mean by that?
Well, since y is the thing that's in like the actual equation itself, I think you can go ahead and plug in 3 and just see what x you get, I guess.
Yeah. Do you get my question?
Margi?
Yeah.
So you want to plug that value in the given differential equation? That's what you mean?
Yeah, I'm just because you explain it with the graph, but I was saying if you don't have the graph, how would you do it? You just
You
plug
have
it
to have the graph. Whenever
You
you're looking for, yeah, you have to have that. That's why we went for the article 1.2.1, existence and uniqueness theorem. So I plotted the graph over there too. Look at here.
Okay, so we have to draw a graph.
You have to have, see, I plotted the graph over here too. And exactly I'm matching, I'm comparing this graph with my this function, whatever graph I drew over here.
Okay.
You have to have the graph. Without graph, you cannot say anything. Because right now we are not solving the problems. Here the differential equation and initial value problem. We are not answering the question by solving this initial value problem. We are not solving because we don't know the method. Without solving, just we are trying to figure it out whether this initial value problem has a solution or not. Right? If the solution doesn't exist, there is no point to solve it. You can't get any solution. Right? You are in the reverse direction, that you want the solution, and then after you want to make sure whether that solution is a solution or not. But that's not the way of learning. Are you getting me? I got your
When I
question
get to your
completely
point, I'm
now.
just like,
Yeah, you
plugging
want to
it
just
in.
plug the value. You want to solve this differential equation. You want to use the initial condition, and then after you want to make sure whether that solution exists or not. But no, that's not the way. It's something like this. Look at over here. How can I explain to you? Yes, suppose you want to go from, you are in North Carolina, right? Suppose you want to go from North Carolina to Washington, D.C. And suppose you are taking the route 75, Interstate 75. Now there is some blockage. Some accident is there, road is closed. So what you want to do, you want to go over there. You want to go over there, in your opinion, Margie. You want to go over there. You want to make sure that whether actually the accident happened over there. If it is there, road is blocked, you would like to come back. No. The good thing is try to fix some way so that you can come to know whether if you go over there, would it be possible for you to use that route or Interstate 75? No. If no, don't go. If yes, okay, go ahead. Are you getting me?
Yeah.
Something like this, yeah. Sort of, something like this. That if you are certain that you are going to get the solution of your initial value problem, go ahead and solve the differential equation. But this theorem says that just like this 5, 3. 5, 3 means y at 5 equal to 3. Y at x equal to 5 is equal to 3. Initial value initial condition, solution does not exist. What is the need to solve that one? What is the need to go over to use route Interstate 75 if you will not go through it? Are you getting me?
Yeah, that makes sense. Thank you.
Yes. So it is like this. I'm sorry, I just took some time to understand your problem because you are thinking a reverse direction. Just go straight. Make sense? Okay. Okay, guys. So that is article 1.2 and 3 I covered, and now we are going to start article 1.1. Yesterday we covered, and 2 and 3 we covered today. Now we are going to start chapter 2. One more thing. Today is Wednesday. Let me finish. Don't speak in between, please. Please don't speak in between. Let me finish my sentence first. Yes, I'm trying to finish your syllabus for the first test on Friday. Saturday, Sunday, holiday. Monday is Memorial Day. Am I right? So
yes, sir.
So you are taking your first exam on Tuesday at 9:45. I am going to collect your practice test assignment as a homework on the same day. I am going to post your exam in the Canvas assignment section. Once I post that one, you have to submit your exam and your homework, both the files separately in your assignment folder of Canvas. That will allow me to grade your exams and your homework directly online. I am going to use the grade spreader, something like that. That software is there. So I'm going to use that one to grade your exams. And you will come to know what you made wrong, what's the problem, everything. When I cut your points or when you lost the points, everything you will come to know this thing. So please make sure that you are submitting your exam on Canvas in assignment folder after I post the exam. Before that, it won't allow you. Unless I post the exams, some document, it won't allow you to submit anything. Okay? Elias, question.
Yes, sir. We did parts A and B for question number 5, where we talked about whether or not they're in the domain. Would C and D, neither of those exist, correct?
I don't know. What is C and D? Go ahead.
Let me see if I can pull it up at this.
Oh, I have it up. It's 2, -3 for
See,
C.
2 and -3, right? Now 2 and -3. Look at over here. 2 is over here. -3 is over
Right.
here. Again, the same situation. It's lying on the
Right.
line. So, and that line is not a part of our common domain. So, you say
Yes, so no.
not, yeah, does not
And
exist.
it would be the same thing with 1, -1.
1 and -1. 1 and -1 is over here. That is
Or
not in the part
-1.
of the same thing.
Right. Right.
Right?
Makes sense.
Okay, good. Makes sense?
Yes, sir. Thank you.
Yes, sir.
Right.
Sir, I had a question about the exam. Is it like, are you gonna post it on Canvas and then we have to print it out, like write it and then scan it back onto Canvas as a PDF, or is it gonna be like a Canvas quiz where you just input the numbers and then submit it?
No. First option, you have to take the printout, write it down, then scan it and submit to Canvas.
All
If you
right.
don't have scanner, use your cell phone. There is a scanner, one app, scanner is there. I'm using that app. That's very convenient. Just once you are done with your exam, take the pictures. You will be allowed to take 10 pictures at a time. So our exam is just 4 or 5 pages. So that's more than enough. Take the pictures, scan it. You will save that one over here in your email. And then you can use your laptop or computer and post it over there on the Canvas.
Okay, thank you, sir.
How long do we do it over the entire class period? Is that like the
I'm not getting it again.
is the time like we're given to take the test just the entire class period?
Oh no, that's a good question. No. If this course is taught on Monday, Wednesday, Friday schedule, the exam time period is 50 minutes.
Okay.
If this course is taught, I'm talking about the regular semester. If this course is taught on Tuesday, Thursday, the regular time period is 1 hour 75 minutes. So I would like to go for the mean of these two. So approximately your exam time is 1 hour. So we can start at 9:45 and you have to stop at 10:45. That's it. Now, after 10:45, it is up to you. I leave it to you. After 10:45, if you want me to continue with the syllabus, I don't mind. That's fine. Or if you say that, no, you are tired, because it's a mental, it depends on you that so many people, mentally, they are feeling tired after taking the exam. That's the tendency, human tendency. So if you feel that after exam, you don't want to learn anything more, or you will not be able to learn anything more, that's fine with me. I just leave it to you. I know we have limited time, very limited time. In 5 weeks, we need to finish everything, but I can do it. Don't worry about it. So just decide in between and let me know by Friday whether you want to continue. You want me to continue the syllabus after 10:45 or not. What do you think, Alex?
Personally, after I take this, I'm pretty burnt out. So personally, I would like to not do anything after, but if I can do, if I have to, I can do it.
I feel like that'll be the general consensus. Like most people feel the same way.
All people, they feel the same way, Will? That's what you mean?
I'd say so.
Will, I can just see your ceiling, not you.
Yeah, my laptop's broken, so I have to do
Okay.
Zoom on my phone. So
Okay.
I don't want to just hold up my phone all morning.
Okay.
But another thing, I have a question on the exam. Are we just able to use the provided formula sheets, or is this going to be like an open, like, note thing? Like, could we use the practice test on it, etc.?
No,
Or what?
Yeah, that's the reason, because at the time of the exam, you are not allowed to open any practice test or any of the materials because everything is online right now. So my notes is online. Some of the problems, suppose I ask you, that is with the solutions are there online. So I can't allow you to open your laptop or computer like this or any of the folders at the time of the exam. So I told you yesterday that you have to take the printout of your formula sheet of the exam. You are allowed to look at only the canvas, look at the exam, take the out, and that's it. Then stop everything. Just stay on Zoom. Stay with me, so that I can tell you guys. Yes, because I have to make sure. Of course, that is your responsibility to follow the owner code, VMI owner code, but that's my responsibility too, that you are following owner code to look at that thing. So yes, go to Canvas, take the printout of the exam, close your Canvas, or just stay it as it is, but you have to stay with me on Zoom.
All right. Another thing is, I know you said that there's overall like 5 or 6 formula sheets or something along those lines. How many of those are going to apply to this first exam?
Nothing, just first one.
Just the first one?
Just the first one. When the time will come, I will let you know. Don't worry about this thing. I told you yesterday that 5, 6 formula sheets, 6 will be given to you at the end of by the end of the semester. So right now it's just one, but when the time will come and if I'm going to provide you another formula sheet, definitely 100% I will let you know. So don't worry about it.
All right. That's all my questions.
Okay. Any other question? So Solomon, Harris, Paul, Mustian, Nick, Nathan, Is, Gage, Queen Heart. No question? I think somebody spoke.
Oh, yeah, I have one question. So you said we have to print the exam and then take the exam, and then we have to take the picture of the whole exam and then upload it to Canvas.
Correct.
Could we have a little bit more time? Because that's a lot to do if the exam
It's not a lot to do, but of course, yes. I can give you.
Yeah, because I know, like, if I take it on my phone, then I have to email it to myself after taking the picture and then upload it. So just like that's the whole transfer of documents that might cut out some time.
I understood your concern, but don't worry about it. Unless you submit your document, I will not close the window. Okay, don't worry about it. I will give you 10 minutes more. But my concern is,
I don't know how strict the 10:45 was.
Once you start your exam at 9:45, right, or 9:50, I will give you 1 hour just for your exam, and submission time I will give you some extra.
Okay.
Make sense?
Yeah, that makes sense.
Happy, all you guys? I will give you extra time for the submission. Don't worry about it.
Yes, sir.
Yes, Queen Heart. Any question?
No, sir. I'm just signing on.
Hello, your voice is getting echo. I don't understand. I can't hear you. Hello? Okay. Let's start, guys. Oh, okay.
You said there was 4 tests. Is that included, or 4 or 5 tests? Is that included in the final exam?
4 tests plus final. Total 5 tests.
Okay.
Okay, guys. Chapter 2, first order differential equation, autonomous differential equation, whatever we did just in the last example, that was the autonomous differential equation. Whenever your y dash dy by dx is a function of just y, function of dependent variable, that equation is called an autonomous differential equation. Look at over here, dy by dx 1 plus y square. And that's what we did, square root of y square minus 9. So it was an autonomous differential equation, I told you. But here, this is not the autonomous. This is non-autonomous because it includes the independent variable too. Right, now critical points, calc 1. If you compare this one with autonomous equation with, if you equate with 0, you are going to get the critical point, or it is called the equilibrium point. Sometimes it is known as stationary point too. Okay, now we are going to see the phase portrait. We are going to see the phase portrait. dp by dt, this is the standard autonomous differential equation. dp by dt equal to p times a minus bp. dp by dt. Previously we wrote dy by dx now it is dp by dt. T is your independent variable, P is the dependent variable. P depends on T. PA minus BP, we are going to use this equation in chapter 3 also in application. So please keep this equation in mind. dP by dt equal to P times A minus BP, where A and B are the positive constants. Because this is constant, P is the dependent variable, that is f of P. That means it is called the autonomous differential equation again. If you equate to zero, zero product rule, either P equal to 0 or A minus BP equal to 0. P equal to 0 or P equal to A divided by B. That means you have, whenever you have this type of situation, then always, these are your actually critical numbers, P equal to 0 and P equal to A by B. These are your critical numbers. Once you have your critical numbers, that means put these numbers on Y, just one axis, that is called P axis. So this is 0, 0 and A by B. Put one dotted line over here and dotted line over here. That means you are dividing your region into 3 different parts. One is below 0, one is between 0 and A by B, one is above A by B. And then after, we are going to check the behavior of the function in all these 3 phases, 3 domains. That's why this is called the phase portrait. That's the reason this one is called the phase portrait. So in first domain, your P lies between negative infinity to 0. Second is negative infinity to, sorry, A by B, my bad. Negative infinity to 0, sorry. Or other way around, you can say negative infinity to A by B to 0, and 0 to negative infinity. Or negative infinity to 0, 0 to A by B, and A by B to infinity. Like this. So 3 different phases are there. Example. If you take the example, this is now example number 6 in your practice test. Example 6a. Just pay attention, guys. dy by dx equal to y minus y cube. Y minus y cube. Y minus y cube, just a function of y, so it is f of y. Initial condition is y at 0 equal to y0. Good. First thing is, whenever you are working, you want to draw the phase portrait. First thing is y minus y cube equal to 0, equate to 0. So you are going to get your initial, critical points, y equal to 0 and y equal to plus or minus 1. Y equal to 0 and y equal to plus or minus 1. Don't look at the picture. I'm drawing the picture for you over here separately. So y equal to 0, dy by dx equal to y minus y cube. And that is my f of y. And y at 0 equal y0 initial condition. So y minus y cube equal to 0, y common 1 minus y square equal to 0. So y equal to 0 and y equal to plus or minus 1. That is the thing. We figured it out. These are the critical numbers. Exactly same whatever is there in your screen. Y equal to 0 and y is equal to plus or minus 1. Y equal to 0 means this one, y equal to plus 1 is this one. This is y equal to 1, y equal to 0 and y equal to negative 1. Can you see here? Y equal to negative 1. Yes or no? Say something.
Yes, sir.
Yes, sir.
Okay. Y equal to 0. Right? Critical number. Now, again, I am starting with my f of y equal to y minus y cube. Separately. Look at this block, side block. Fy equal to y minus y cube. Choose the points from each of these phases. Choose the point from each of the phases. I mean to say that in the first phase, here it is y equal to 1. Y equal to 1. My first phase is this one. Let me choose one point. Suppose y equal to 2. Then I'm in between 0 to 1. I'm going to choose y equal to half. 0 to negative infinity. I'm going to choose y equal to 1 or negative 2, whatever it may be. Right? Y equal to 1 and y equal to negative 2 here. Like this. And I will check the behavior of the function in these different 3 phases. So my f of suppose 2 minus 8 equal to negative 6, so it is less than 0. F of half equal to 1 by 2 minus 1 by 8, and that is equal to greater than 0. F of negative 2, that is equal to -2 minus plus 8, that is equal to 6 greater than 0. So less than 0, in first domain, it is less than 0. Less than 0. Right, guys?
Yes, sir.
Function is decreasing. Greater than 0 means function is increasing. So decreasing function, just by roughly, I would say my function is decreasing in the first domain like this. In the second domain, my function is increasing. So increasing function, I would like to show like this. Function is increasing, roughly. In the third domain, again, function is decreasing, right? Y equal to 1, -1, and my third domain, my function is y equal to 1 and 0, plus or minus 1, right? So -1 is also there. Okay. There I was. My function is decreasing in third domain. So my function is decreasing. Look at here. My fourth domain, 1, 2, 0 to 1 by 2. I forgot f of -1 by 2. I'm sorry. F of -1 by 2 is less than 0. Okay, so decreasing. And f of 2, f of -2 is increasing. So f of -2 function is increasing. So I can draw like this. I can draw like this. Now I can put couple arrows. Look at over here. How? In the first phase, function is decreasing. So let me put a downward arrow. Downward. Can you see here? Downward arrow. Arrow moving.
Yes.
Yes or no?
Yes.
Yes, sir.
Now second phase, it is increasing. So upward arrow. Upward arrow. My third phase, it is again decreasing. So my downward. My fourth phase, it is increasing, again upward arrow. So I'm getting my arrows like this. Agree. Agree.
Yes.
Yes, sir.
Okay. Okay. Now, whenever two arrows are approaching each other, one arrow is decreasing downward, another arrow is upward. So when two arrows are approaching each other, that is called attractor. In my first and second phase, you can see this is downward, this is upward. So approaching each other, that is called attractor. And whenever two arrows are in opposite direction, one is on upward, another is on downward like this, then that is called the repeller. Repeller. So let me write like this: attractor, ATTRACTOR, and REPELLER. Repeller. Attractor, another name is attractor, means it is asymptotically stable solution. Asymptotically stable. And repeller means asymptotically unstable. Asymptotically unstable. Okay. You want the picture of this one? Do you want the picture of this one, whatever I wrote it down here?
Yes, please.
Yes, please.
Yes, then let me do one thing. How can I send the picture to you? Let me find some way out. Okay. Nina,
Yes, sir.
do one favor for me.
Yes, sir.
Send your cell phone number in my email, and I will take the picture and send it to you in your phone, and you can forward to all other guys. Is it okay for you?
Send my phone number to you.
In my email. And I will send these pictures to you, and you can forward to all other guys. Is it okay? Thank you. Please send it to me.
I just sent it to you, sir.
Hey, who is Fiorillo? F-I-R-I-L-L?
Oh, that's me, sir.
Oh, that's you. Oh, you sent
Yeah,
me.
I sent you an email. I mean,
Okay.
Yeah,
So
it
you
just wasn't open yet, but I got it. So
Hmm.
no worries.
Okay. It is 05, right, Rodriguez?
I'm sorry, sir?
Last 05, right?
Yes.
Okay. You will get my number now.
Yes, sir.
Okay. You're in New Jersey, right?
I haven't gotten anything yet.
You didn't get anything? Okay. You will get it. Just wait. RODRIGUEZ, right? RODRIGUEZ. Okay.
Oh, sorry, sir. I mistyped my own phone number. It's 5505, not 5005. I'll send it to you again.
Oh my gosh.
I'm sorry.
5505?
Yes, sir. I resent it to you. I'm sorry.
It's okay. Oh my gosh. How can I now? 5505, right?
Yes, sir.
There's your cell phone, right?
Yes, sir.
Did you get my call?
Yes, sir.
Okay.
Just got it.
Okay, so I'm sending these pictures to you, all 3 pages.
Okay. I think I can attach it on Canvas in the discussion section if that makes it easier so I don't have to.
That sounds good. Yeah, that's fine.
Okay, I think I can do that from my phone.
Yeah, that is easier for you too. That's good.
Yeah, in the discussion section I can.
Yeah.
Okay.
Yep. So I sent 2 pictures to you. It will take some time to reach to you.
I just got one of them.
Okay, that's good. Yeah, second one is on the way. Yeah. Okay, guys, so that's a repeller. Second example, I took both examples from your practice test. I don't want to go through the second example. It's exactly same. Just try to convince yourself. If you have some doubt, we will discuss this thing tomorrow, but it's exactly same than the first one. Second one is separable variable. Now, guys, I have one question. I want to discuss something with you. What? Nina, I think you got both of them, right?
Yes, sir. I just got them. I'm posting them on Canvas now.
That's good. Okay, good. So this will go to the dustbin. Good. Now, guys, look at here. All of you, I want to talk to all of you right now. Let me make big screen. Your first day syllabus will be over by tomorrow. Yes, tomorrow is Thursday. So technically, you can take your exam on Friday. So I leave it to you when you want to take your exam, Friday or Tuesday. When you want to take.
If we chose to take it on Tuesday, would Friday be new material that wasn't on the exam?
Exactly. If you choose on Tuesday, in that case, I can't spare one day like this, we can start. We have to start with the new material.
I would rather take it on Tuesday because that gives us the entire 3-day weekend to study for it.
Yeah, that's how I feel.
Yeah, I agree.
Girls.
Personally, I'd like to take it on Friday.
Yeah, I guess for me, I'd rather take it on Friday, but it depends. Like, if it's similar to the practice test and we have to do that before the test, then I'm fine. But if we have to like look through all the notes again, then we might want more days.
So
Yeah.
no, it's similar to practice test. Yes.
That's say Tuesday.
So I've been
Example.
doing practice tests as I go, so I feel like I'd be ready on Friday, and it'd just be good to get that out of the way instead of learning new stuff. But
Yeah, I feel like it'd get confusing if we learn new
yeah, especially
material.
if it's like 2 hours.
For me, I believe that if you take on Friday, that means you can enjoy your weekend. But if you want to take an exam on Thursday, on Tuesday, at that time, you know something will be pinching you every time on the weekends that you have to be ready with the exam. You have to be ready with the exam. Just avoid this tension and try to take the exam on Friday. But that's my opinion. I leave to you. My opinion. I will go for the majority.
But my vote's Friday. That way, especially over Memorial Day weekend where I know a lot of people are taking trips and everything.
Yeah, like I'm getting out of town, so.
Yeah.
So how many of you are in favor of Friday? Please say 1, 2, 3 like this. Margie, 1. Then next one is
Will, 2.
Will.
Campbell, 3.
Then just 2.
Is this for Friday, sir?
Yeah, for Friday.
Then I want it Friday.
Okay, 3.
I'm for Friday as well, sir.
Okay, Nick, that's good. That's really good choice. Yeah, 5. Nathan Light, 5. Then please pick something. Don't raise your hand. Please pick something. No.
Friday sounds good to me too.
Oh, Gage.
Yes, sir.
Okay, so 7.
I feel like that's the majority, sir.
Yeah, I guess we're doing it Friday then.
Oh, you too, Alex?
Oh, I mean, I think they already got the majority, so.
You only got the majority? Okay, that's fine. So
Yeah.
let's go on Friday, right? I think that's really good for you guys. If you
works.
think it positively, yeah. And we can do one thing. See, I'm going to finish your syllabus. Take the test on Friday. Honestly telling you, I am going to finish your syllabus tomorrow in first hour. That means we will be having more time. Rest of the times, I am not going to start the new chapter. I mean, it's the new things. We can do one thing. After finishing the syllabus for the test, we can review the things. But if
that'd be
you are
perfect.
planning on Tuesday, I'm not going to give you any review. Are you getting me?
Yeah.
Right? So let's do like this. And main method starts from article 2.2. So first method is separable variable. Separable variable, dy by dx equal to y square minus 4. Just look at over here. The first method, very easy method. Once we are done with this method, we are done for today. The rest of the methods we will be doing tomorrow morning. Good. So, okay, separable variable. Separable variables means we are separating our variables x and y. Dependent variables, independent variables, we are separating these two variables. My first example is dy by dx equal to y square minus 4. Y square minus 4. So let me take this y square minus 4. Let me divide throughout by y square minus 4. Or first I can use a differential. Send this dx to other side. Y square minus 4 over here. Cross multiplication. So you're going to get dy one side your y, one side your x. If you go for the integration, dy over y square minus 4 equal to dx plus c. Integration of dx is 1 is simply x plus c. Here it is y square minus 4 is 1 over y minus 2 and 1 over y plus 2. It is y square minus 4. So that's why you have to be very careful. You are integrating. Now see your calc 2 starts. Right from this point to the up to the end of the syllabus, we will be using now calc. Every time, every after 10-15 minutes, we will be using calc 2, calc 2, calc 2. So how can you get the integration of 1 over y square minus 4?
You You want to separate it. So
Yeah. We
factor
can
it.
write it down. We can take the factors y minus 2 and y plus 2. But now, how can we go for this one? Y minus 2 and y plus 2.
The partial fraction.
Why partial fraction?
Because it's 1 over the factors.
1 over factors means? You're right. You're right. Go ahead. Whenever you have, guys, look at here, all of you, whenever, okay, Gargi, I'm sorry, Margi. Yes, why, he said that we can go for the method of partial fraction. My question is why? Did you learn this thing in your North Carolina University? Yes. Why he said partial fraction? Why partial fraction?
I'm not exactly sure.
Not exactly sure. Anybody else? Nina, you must know this thing.
I would just say because since you can factor the bottom, I guess.
You factor the bottom. That's what I did. But so what? Will?
Sir, I have no idea.
You
Yeah,
have no idea. Just set up your camera, right? I want to see you. Your smiling face.
Yeah, I'm right here. I just don't want to
Right
hold
here.
it.
Okay. Okay. Guys, look at here. Whenever, see, mathematics cannot be learned blindly. You have to ask number of questions to yourself and satisfy you. That's the best way of learning mathematics. Am I right, Gage? Gage? Good. Whenever you have a product of two functions in denominator, you don't have any choice except partial fraction. Product of two functions in denominator. That's why we are using partial fraction. If you have product of two functions in denominator, at that time you can use u into v rule. Right? That we will see later. No, you know this thing, u into v rule, right? Calc 2, yes.
Mm-hmm.
So whenever you have product of two functions in numerator, if you want, please write it down. Whenever you want to integrate the product of two functions in the numerator, always think about u into v rule. Whenever you have product of two functions in the denominator, always think about the method of partial fraction. That's the reason Alex said method of partial fraction. Am I right, Alex?
Yes, sir.
He said two function, but actually that was not the complete sentence. Anyway, but he got it. Good. So I have put product of two function. Method of partial fraction goes like this. Look at here. 1 over y minus 2y plus 2. So a over y minus 2 and b over y plus 2 because linear factor. That's why. So a and b, right? Once you have a and b, just I'm working on left hand side, right hand side. I'm working anything this side. So just pay attention here. Now what I'm doing, a y minus 2 and b y plus 2. My denominator here is y minus 2 y plus 2. So take LCM. You know how to take LCM, right? Today morning, one of my Calc 2 students, he disappointed me. He was asking me a plus b over c is equal to how it is ac plus b over c. Yeah. A plus b divided c, or 1 plus 3 over 2, that is equal to 5 by 2. And he got surprised how it is 5 by 2. And I spent 15-20 minutes with him. That's not fair, right? I hope you know this method of least common divisor or least common multiplier. So y minus 2 y plus 2 is cross multiplication. So a y plus 2 b y minus 2 divided by y minus 2 y plus 2. Common denominator here and here will get cancelled out. So 1 equal to a y plus 2 and b y minus 2. Okay, see, common denominator gets cancelled out. Y plus 2 and y minus 2. Now, if I take suppose y equal to negative 2, y equal to negative 2. So this will be 0. This is negative 4b. Excuse me. Yes. Where I was. Yes. So b equal to negative 2, negative 2, negative 2, negative 4b. So b equal to negative 1 by 4. If you take b equal to 2, sorry, y equal to 2, that means b is 0. 2 plus 2 is 4. 4 equal to 1, a equal to 1 by 4. A equal to 1 by 4. A equal to 1 by 4. Go back and plug these values of a and b over here in your main math partial fraction part. If you do like this, 1 over 1 by 1, y minus 2y plus 2 equal to 1 by 4, and this one. Partial fraction separates your product in terms of plus or minus sign like this, so that you can integrate each function separately easily. That is the use of partial fraction. Right? So I plug this value now, because it's equal to this, I plug this value over here. And integration. Okay, don't look at your screen. Just look at, I will say, just look at the screen. Don't look at your material. What is the integration of 1 over y minus 2?
Ln of y minus 2.
Say again.
Ln of y minus 2.
Ln of y minus 2.
Yeah.
1 over y plus 2. Ln of y plus 2. Agree?
Yep.
Okay. And x plus c. Let me send this 4 to other side. So 4x plus c. 4c. 4c is c1, you can say. So ln of y minus 2 or y plus 2 equal to x plus c. Ln of a minus ln of b is ln of a minus a over b. Ln property. So ln of y minus 2 equal to 4x plus 4c. Logarithmic function and exponential function, they are inverse of each other. So if you want to cancel this ln over here, you have to multiply here e to the power some, this one. So e to the power 4x plus 4c. So y minus 2 over y plus 2 equal to this one. This e to the power 4, a plus b is e to the power a plus into e to the power b. But this is constant. So I would like to put some constant c1 in place of this one. So c1 e to the power 4x. So y minus 2, because it is exponential function, and if you want to remove this absolute value, that means you would write plus or minus sign. So y minus 2 over y plus 2 equal to plus or minus c1 e to the power 4x. So y minus 2 equal to plus or minus y means multiplied with this one. c1 e to the power 4x plus or minus 2 c1 e to the power 4x. This one. I have y over here on left side. I have y over here on right side. So let me combine all my y's just on one side, left side, and my 2 and 2 here on right side. So I send this 2 to the other side, this y to the left side. So this plus and minus on left side would be converted to minus and plus, right? Because this y with plus sign, here it is minus sign, or minus sign, here it is plus sign. So minus plus, please make sure.
I have a question.
Yep.
Why did it become c1 e to the 4x?
Because I don't want to continue with the whole constant e to the power. E is constant, 4 is constant, c is constant. Every time, I don't want to go through this whole constant. I don't want to repeat.
Okay.
So I just put one symbol, because see, if I say 5 square, what is 5 square? Or 5 square?
It's
5 square is 25
25.
and square is 625. Why not to write 625 instead of 5 square every time?
All right.
That's
I
the
get
reason.
it. Okay.
Okay, so y minus 2 equal to this one. One side it is y plus minus plus, and 2 other side it is plus, and this is plus minus. I can take 2 common outside and 1 plus or minus this one, and I can take this y outside, and here it is 1 minus plus, this is minus plus. c1 e to the power 4x. c1 e to the power 4x. I divide by whole this factor, both the sides. So I'm getting yx. Yx equal to 2 1 plus or minus this one divided by this part, 1 minus plus C1 e to the power 4x. That is the solution. That is the solution. I am not given any initial conditions, so I will leave this one as the solution. So separable variable means first you separate the variables, then use the technique of your calc2 and get the solution. That's it. Any doubt?
I'm still a little confused why the e to the 4c you could just convert it to c like that. Like what happened to the 4 and everything?
Which one?
If you go up. Yeah, the one you circled and drew the arrow. That part. I know he asked the question. I'm still confused.
Oh, I think he asked me the same question, Alex.
Yeah. Yeah,
See,
I still.
is constant?
Mm-hmm.
Yes or no? I'm asking you, Margie. E is constant?
Yeah.
4 is constant?
Yeah. Oh,
C is
so
constant?
whatever, it doesn't matter because C is a variable anyways.
The whole constant, I don't want to repeat every time. That's why I just put the symbol C1. If you want to work with e to the power 4c, I don't mind. That's fine.
So from the start, when you put in like 4c, could you just turn that into C1 or do you have to do it at that step?
Which one? 4? Repeat, please.
Yeah, like at the beginning, you had like 4x plus 4c. Could you?
4x.
Like,
wait. That is 4x. 4x plus 4c. This one, yes. Yes. Then?
Could you just convert like the 4c to C1 like anywhere in the process, or does it have to be at that step?
Again, see, here I have used the exponential form rule. E to the power a plus b is e to the power a times e to the power b. Agree?
Mm-hmm.
You know this exponential rule or not? E to the power a plus b.
Yeah, no, I understand that part.
Times e to the power b. E to the power a is e to the power 4x. Here your variable is there. X is the variable. Dependent or independent, but it's a variable. Here everything is constant. So I don't want to repeat the same thing throughout the problem because that's confusing too. So because I don't want to make any confusion, to avoid the confusion, I just consider this one as constant. C1, A, whatever you want to say. You can say capital A, capital B, some constant, whatever you want to say. Usually we say constant C, C1, C2 like this. So that's why I say this one is my C1. So C1 e to the power 4x. But yeah, that is not always compulsory. You can work with e to the power 4c throughout the problem. I don't mind. Is it okay?
Yeah, it's fine. Thank you.
Mm-hmm. Any other problem, guys? Okay, I know you are tired, but just 2 more minutes. Second problem is way easier than first problem. Sine 3x dx plus 2y cosine cube 3x dy equal to 0. I want to separate the variables sine 3x and dx on one side. 2y cosine cube 3x is there, but let me keep this one other side like this. And now let me divide by this factor because I want x on my left, y on my right. On one side, y on one side. Gauge here. Divide by cosine cube 3x. If you divide by cosine cube 3x, you're going to get sine 3x over cosine cube 3x. Negative 2 integration y dy plus c. Who wants to take for this integration? What is the integration? Sine cube over cosine cube 3x. Any one of you? Sine cube over cosine cube 3x. No?
Oh, would that just be tangent cubed?
Nope. It's cube is there. Look at here. Cube is there. How could it be tangent cube?
Oh, no.
Cube is there. Look at here.
Okay.
Right? Yes. Calc 2. Calc 2. U sub.
Oh, we make u equal to
what?
One
cosine, right? Cosine cubed.
U equal to cosine cube 3x, right?
Yes.
Cosine cube 3x, are you sure?
cosine squared 3x.
Cosine squared 3x, are you sure?
Yes.
I'm sorry, both of you are wrong. See, I don't know, Rodriguez. Nina, who was your teacher for Calc 2?
Patterson, sir?
Peterson, okay.
Major Patterson?
He or she?
He.
He, okay. Huh. What is the purpose of use of? You know this thing, Nina? Or any other guy? What is the purpose of taking use of? When we can use use of is Nathan? Oh, what are you doing, Nathan? We are not done. Can you take use of? Solomon? Ilyas?
Is it just to try to make the problem simpler so that we can do simple
No.
integration? Or
So,
no?
No.
Role or something?
No?
Isn't it like chain rule or
Heart?
it's for like a specific process?
No. Look at here. Whenever you use u sub at that time, you have to make sure that after derivative, you have to have your derivable function in the numerator. If you don't have it, you can't use u sub. You know what I mean? I am teaching right now Calc 2. No, that's not fair. Again, you have to choose your u in such a way that if you take the derivative du by dx, u dash, if you take derivative u dash, you must get your numerator function. Don't worry about the constant. You can play with the constant, but variable function must be there. Now look at me. That's why I don't like these things. See, you guys have just finished your Calc 2, and even though you are not sure about this, if I take suppose cosine 3x as u sub, forget about cube. Cosine cube 3x can be considered as cosine 3x whole cube. Agree? Yes or no? Cosine 3x whole cube. So I can consider cosine 3x as my u sub. Now what will happen? See here. If I write, let me write over here, u equal to cosine 3x, right? Good. Now what is derivative of cosine 3x? Nick?
Would it be 3 cosine 3x, sir?
3 cosine 3x, are you sure?
Not entirely, to be honest. I
He's
think
wrong actually. He's not 3 cosine 3x.
Negative 3 sine 3x.
Correct.
Okay.
Cosine 3x derivative is, suppose 3x is your u or p. So derivative of cosine 3x is negative sine 3x and derivative of 3x is 3, chain rule. So negative 3 sine 3x. Am I right? Nick?
Yes, sir.
yes, sir.
Right. I know you are tired. Just give me 2 minutes, please. I will compensate this time, okay? Tomorrow or some other time. Okay, u dash equal to negative 3 sine 3x. Now, negative 3, u dash means du by dx, right? Du by dx equal to negative 3 sine 3x. So du equal to negative 3 sine 3x and dx. Am I right, guys? Look at the screen.
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
All of you?
Right.
Solomon, Harris?
Yes.
Good. Right? Now what I want, look at the screen. I want just sine 3x dx. I have the additional factor negative 3 over here. Divide by negative 3. I told you, you can play with the constant. Am I right, Ilyas?
Yes, so that makes sense.
Nathan?
Yes.
Nathan. Okay. So if I write du,
If you divide it over,
du divided by negative
they
3
just
equals
pull it
to
out.
sine 3x dx. Shall I write like this? Shall I write like this?
Yes, sir.
Now plug the values. So if you plug the value here, you're going to get sine 3x dx is your du. Negative 1 by 3, I can pull it out because it is constant. So 1 and sine is u and cube. Shall I get like this? Convinced? Negative 1/3 du, I wrote it down like this. Negative 1/3 is constant, pull it out, du as it is, and 1 over u, your cosine 3x, and cube as it is. Does it make sense?
Yes, sir.
Now use power rule. Use power rule. So negative 1/3 and u to the power negative 3 du. That is 1/3 u to the power negative 2 divided by negative 2 plus c. This is your answer. Means your left side integral. Agree?
Yes, sir.
Okay. And you're done. Look at here. See, and plug the value of u. So u is cosine squared 3x, negative y squared plus c. And that's the answer. Okay, guys, sorry, I took just 5 more minutes, but I told you, we will compensate this time. So this is the separable variable. And one more example is there. Maybe we'll discuss tomorrow. The rest of the things we will be doing tomorrow. So let me stop over here. Okay, guys?
Yes, sir.
Sounds
Yes,
good.
sir.
Okay, guys. Thank you so much. Thanks for your patience. And work hard. If you have some doubt, we will discuss tomorrow. If you don't have any doubt, that sounds good to me. Right?
I have one question. If I were to work on the practice test tonight, could we go over like some questions that are harder or the ones we don't get tomorrow during the review? Is that fine?
That's fine.
Okay.
Okay, guys. So let me stop over here. Thank you so much. Bye. Take care. Stay happy.
Good day, sir.
Have a good day, sir.
Have a good day, sir.
Have a good, sir.
Thank you. Bye. Thank you, guys.